Good morning, sir.
Good morning,
sir.
Good morning.
Good morning, sir.
Good morning. Fine. In last class, we were discussing about VLSM.
Yes, sir. We have discussed.
We have discussed. Now we have to go for supernetting, then after routing.
Yes, sir.
Okay. Just I'm going to share my screen. Now this is supernet. First, till now, we have seen that we can use IP classes with all default settings or with all default values to define different network, first thing. Then after, for saving of IP address, we have studied about subnetting process and VLSM process. But suppose if you have to connect approx 300 machines in a network, but IP should be of class C, then there is a concept to combine two or more series of default IP address to form a large network. In case of class A, we can connect a 16777.216 host 214 host in a network. In class A, it is enough. In class B, we can connect 65,536, not 36, 34 hosts in a network. It is also enough. But in class C, we can connect maximum 254 nodes in a network. And if we have to connect 300 or more than 300 nodes in a network, but there is a compulsion that IP should be from class C, in that case, what we will do? We can combine two or more different series. This concept is known as supernetting. That's why there is a simple statement: default two or more series of class C are combined to form a large network. Now the question is, can we do it for class B and class A also? Yes, we can do it, but there is no need. Fine. Getting my point?
Yes, sir.
Yes, sir.
Yes. Fine. Now I'm going for example. Just the font is very small. Now font is clear, I think. Now fine. See this example. Suppose there is a requirement of 500 machines in a network. Then, as per our subnetting or VLSM concept, number of network bit will be 9, 512, 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512. Hello?
Yes,
Yes, sir.
Yes, sir.
1, 2, 4, 8, 16, 32, 64, 128, 256, 512. Fine. Then the host bit will be 9. Then the rest bit means 32 minus 9 is equal to 23. 23 will be the network bit. Then on the basis of this 9 and 23 value, subnet mask value will be in binary form. This one.
yes, sir.
Then its decimal value will be 255.255.254.0. Okay, fine. This is a class CI. This is a subnet mask. But in case of class C, default subnet mask is 255.255.255.0.
Yes, sir.
Now you all can see that we are just taking host bit from the default network bit. In case of subnetting, in case of VLSM, we have given bits to network from host bit. But now in this case, for host bit, we are taking value from network bit. Just opposite. Now, fine. Now the first one value is 1, 2. 2. The first one value will be 2 or not?
Yes, sir.
2. Then, as per previous concept, we should add this 2 with 0. I just added 0 plus 2, value is 2, then the range will be 0 to 1. Now, this is 0 to 1, and we are talking about 500 nodes. 500 plus 2, 502 IP addresses are required to in my network. See, but this value 2 is coming from the second group from right to left. So we will make change with this group, second group. Now, IP address 192.168.0. Just see 0. Okay. And from 0 to 1 we can take. Now the final value is 192.168.1. Just see. Here we are using two default series, 192.168.0 and 192.168.1. Now in this case, 192.168.0.0 will be the network IP address, and 192.168.1.255 will be the broadcast IP address for this network. Now, from 192.168.0.1 to 192.168.1.254, all these IP addresses will be the valid host IP. It doesn't matter that 192.168.0.255 is coming. It's okay, fine. It is coming.
Sir, where you are using 0 and a 1, we can use anything, na?
Anything.
9 to 10, 11 to 12.
No. Not 9 to 10. Because this is 0 to 1 value, that's why you can say, suppose that we have to connect 1000 machines. Fine. The second example. For 1000 machine, we will take one more value from network bit. In that case, first bit value will be 4. Then, as per the addition result, what will be the result? 0 plus 4. 4 means first range will be 0 to 3. Second range will be 4 to 7. Third range will be 8 to 11. Fine. So you can take any value. You can take 8 to 11. You can take 12 to 15, 12, 13, 14, 15. Yes, 12 to 15. Getting my point?
Yes.
Yes. So now in this case, we can take 0 to 1 or 2 to 3 and 4 to 5.
Sir, if I need only 500 IPs and I want to start my host my IP from 192.168.11.0, then how we can start?
11.0. Fine.
0.
Just. First range will be 0 to 1. Second, 2 to 3. Third, yes, 2 to, not 2 to 3, 0 to 1, 2 to 3, yes. And 4 to 5. Then 6 to 7. Then 8 to 9.
9.
Then 10 to
11.
11. That's why you cannot start with 0. You have given value 0.11, 192.168.0.11. Fine, Rohit? You would like to start from 0.11, no?
No, sir. 11.0.
11.0. Okay,
yes,
fine.
sir.
11.0. Yes. 11.0. You cannot start with 11.0. As per the range, value will can be 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9, or 10 to 11. Okay.
Okay, so if I want to start from 10, then
10, then it's okay. 10.0 to 10.0 will be the first value, and 11.255 will be the very last one.
So for the same subnet maps now.
For the same subnet.
Okay, sir. Thank you, sir.
Okay. Now this is the concept of supernetting. In supernetting, we can combine 2 or more default series of IP addresses, and it is mostly done in case of class C. Okay. Now
Yes.
this is the basic concept of IP address. Now, before moving to routing, we should discuss about IPv6. IPv6. We have discussed about proxy, NAT. Now this is IPv6. Because there is a question, what is the difference between IPv4 and IPv6? Keep it in your mind. This is a university paper question. Fine. See few points about IPv6.
Sir, there are many differences.
There are many differences. So, if there will be a question in that case, just make two columns, and in those columns, point number 1, point number 2, point number 3, mention differences like this.
Yes, sir.
Fine. In case of IPv6, first thing just about history, introduced in 1998, developed by IETF. IETF is Internet Engineering Task Force, and finally launched on 6 June 2012. Why IPv6 was introduced or launched? Just because IPv4 was exhausted. Finally, we have techniques to use these two IP addresses at the same time by using dual stack concept. We will discuss this concept later. And it has 128 bits. In case of IPv4, but only 32 bits. But in case of IPv6, 128 bits, and these 128 bits are divided into 8 groups, and each group has 16 bits. IPv4 is divided into, is represented into decimal number, but IPv6 is represented into hexadecimal. In case of IPv4, each group is separated by dot, and in case of IPv6, each group is separated by colon. In case of IPv4, it supports across 3.2 billion IP addresses, and in case of IPv6, it supports 3.4 into 10 to the power 38 IPv6 addresses. IPv4 supports unicasting, multicasting, and broadcasting. IPv6 supports unicasting, multicasting, and anycasting. Fine. Anycasting is similar to broadcasting, but for anycasting, link local IP address is assigned to each and every node. And in case there is a need in that condition, with this IP address, anycasting can be done. Anycasting is a process in which a node can communicate with all nodes or multiple nodes. There is no any class. In IPv4, there are 5 classes, but in IPv6, there is no any class. In IPv6, all IP addresses, have I not mentioned? Just there should be one more point. There is no any network IP address and
host
broadcast. In case of IPv6, no network IP, no broadcast IP. All IP addresses of a network can be used to configure at a node. Fine.
Yes, sir.
In case of IPv4, as per the class, number of default network bit and host bit are different. But in case of IPv6, default network bit is 64 and host bit is also 64. Then total bit is 120. Fine. And here there is no any subnet mask. There is no subnet mask like we have used in case of IPv4 255.255.0.0 or something like that. In place of subnet mask, subnet prefix length is used. And in subnet prefix length, network bits are represented. How many network bits are present in the IP address? And the default value is 64. As we have seen in IPv4 that in case of IPv4, we can use the same thing that is known as slash notation of IPv4 address. See, slash notation of IPv4 address. I think I have discussed this. Yes, this is the slash notation of IPv4 address. Suppose this is class A IP address and its default subnet mask will be 255.0.0.0. But if you do not want to use this subnet mask, then we can represent this IP address with subnet mask like this. 10.0.0.1/8. What is 8 here? 8 is the number of network bits present in subnet mask. If you will convert this subnet mask into binary, in that case, you will get 81, 8 zeros, 8 zeros, and 8 zeros. Fine. So, total number of network bit is 8. That's why we can represent these two values in a single line by using slash. IP address, then slash, then number of network. Suppose we have to do it with class B. In class B, there are total 16 network bits. That's why we can write here like /16. In class C, there are 24 network bits. That's why we can write it here like /24. This is slash notation of IPv4. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
The same thing is used in case of IPv6 also. And here it is known as subnet prefix length. In IPv6, we do not use slash. In place of slash, we can use 64. But if you will see the routing table information, in that case, you will again see that this 64 is also represented with slash. Means IPv6 address, then slash, then 64. Fine?
Yes, sir.
Now, just see the format of IPv6. In case of IPv6, total 128 bits, and these bits are divided into 8 groups. And in these 8 groups, first 4 groups are used to represent network bits, and last 4 groups are used to represent host bits. Fine. And in every group, there are 16 bits. Then in this case, if you would like to know about the flow of IPv6 address, the flow will be will start from all 0 value and then will end with all F value. Because IPv6 is represented into hexadecimal number. And in every group, we are using 16 bits. And with the help of 16-bit, we can form maximum 4 hexadecimal numbers or hexadecimal characters. That's why in every group, there are 4 hexadecimal values. And the first value will be 40 and the last value will be 4F. Fine. Hello.
Yes, sir.
Yes, sir.
Now, few more points. Abbreviation can be used. Abbreviation can be used means we can remove zeros, and in place of continuous zeros, we can put single colon. I'm discussing it in a fast manner because I have already taught you. I am repeating this statement again and again. And if there are few zeros before few different values, in that case, we can also remove it. Like in this group, you all can see that 001A. So we can write this value like only 1A. We can remove these first 2 zeros. Fine. The very first IP of IPv6 will be all 0. And if there are all zeros in every 8 groups, and then the subnet prefix length is 128, then this type of address is known as unknown address. There is known. But if all characters are 0, and we are using subnet prefix length 0, then this value, this IP address is used as a default. And in case of IPv4, we have used 0.0.0.0 as a default route. If the starting all characters are 0 and in the last group there is 1, then this IP address is known as loopback IP. Means very first and second IP are reserved IP. First IP will be used for default route and second IP will be used for loopback addressing. And in case of IPv4, we have seen for loopback testing, as a loopback address, IP is 127.0.0.1. Fine. And what about link local IP address? It is assigned automatically to every node and it always starts with FE80. There is a concept of multicast IP, and multicast IP always start with FF0. For example, FF05, FF06. These two IP addresses are used for multicasting, but in case of OSPF. And if you will see, in case of IPv4, 224.0.0.5 and 224.0.0.6, these two values are, these two IP addresses are used for multicasting in case of OSPF. Fine. So with the help of these points, you can easily differentiate between IPv4 and IPv6. If you have to explain about IPv4, you can explain. If you have to explain about IPv6, you can explain. Clear? Just leave this point, EUI format. Is it okay?
Yes, sir.
Yes, sir.
Sir.
Okay, fine. Now I'm going to drop
IPv6, why are you dividing, sir?
4 group is a network part and 4 group is a host part, sir. Why, sir?
Why I'm not dividing it? It has been divided by the developers to form different networks, and in different networks uh, to connect different nodes. Network bits are used to define different network, and host bits are used to define different hosts in a network. Okay.
So can I get, sir, 2 group is a network part and others host part?
For example,
Two,
you are. I think you are asking for example.
yes,
Hello.
yes, sir, yes, sir.
Just see this example. This is the first first network, and here the network value is 2000:A::B:1. I have decided these 4 values only to define a network, and just see the second example, 2000:A::B:2. This is the second network example, because I have made change with a single value. If there is a single value change, there is a different network.
Okay, sir.
Fine. Just wait.